Hello everybody, CJ here, your local friendly technology addict, and you're watching the Tech Addict's Attic. I think I'm going to have a short one today. So I've got my special microphone setup going, so hopefully you all can hear me, and hopefully I'm not too loud. I'm sitting here, I'm constantly looking right about where my finger is. I've got a VU meter, and I'm constantly trying to make sure I'm not overpowering the mic, because if I do on this particular mic setup, it cuts out the audio. So anyway, I've got myself here a little project that I've been working on, and for the rest of this video I'm going to not be in it. I'm going to show you what I've got down here. So obviously we have a telegraph key and an Altoids 10, and this took a fair deal of thinking, mainly in how to wire the switches, because I wanted it to where I could turn this switch on and that would turn everything off. No voltage is being applied. Right now the battery is disconnected. Yes, there's a battery in here. I've got a little 9-volt rectangular. So when this switch down here is on, everything is technically off, and I'm going to have a jack where I can plug in and go to a transceiver, and this will become a live key for actual CW, whether I do contesting or just a regular QSO on the air. I then have this button, and this button will be my code practice oscillator. With this button on, I have keyed going to the key, well, power going to the key and to the audio amplifier, but keyed power going to the code practice oscillator circuit. So basically, the only thing powered right now, aside from there being voltage on my key, is the audio amplifier, which of course, if there's no audio to amplify, won't be taking a whole lot of current. It will be draining the battery some, but not much. And even if I were to turn the audio amplifier on by itself, now with the audio amplifier, the key turns into a push-to-talk switch, for which my attached microphone, and let's see if I can turn this around here, you can see it. I've got a little jack there, a little 1/8 inch, 1/16, whatever the tiny one is, the real tiny one, little TR connector. And of course, I haven't fastened it to the base yet. I haven't decided what direction I want it to be. I think I'll just keep it in this orientation. But anyway, this key now becomes a push-to-talk switch for the microphone that I have attached here. Now, of course, this microphone is a dummy mic. It's only a temporary solution, so I can test things out and get a feel for what it is I really want to do. And I plan, after I could probably get goosenecks for cheap on Amazon, but these came off of a couple of lighters, those little fireplace lighters, water heater lighters, whatever. And one of them still has, I didn't pull the wires out of it because I can still use those. I'm going to put an electret microphone on the end of it, and that's going to become a gooseneck. I'm going to build a base for it and everything. But I need to get another lighter because those are too short and I need to connect them end to end. It may look kind of ghetto with the connector in the middle, but I really don't care. It's going to be awesome because it's homemade, and that's the point. I want this to be homemade. I don't want this to be just, you know, a hodgepodge of commercially available products, although that would look better. But I want to see what kind of jury rig I can come up with. I could also even manufacture my own key if I wanted to. There's nothing to a key, so I could do that as well. That's a project for another day. Anyway, so I've got everything off, code practice oscillator, and push-to-talk microphone. This one does nothing. However, with this one on, this one is off, so there's actually voltage being applied to the key, and I don't like that. So by doing that, I turn off everything. Basically, the battery is disconnected inside. So I'm going to put the microphone next to my computer speakers over here that I've got hooked up. I do have a bit of a jury rig because I don't have a TRRS or a TRS jack for this. I do have some cables with TRRS connectors on the end, but I don't have any jacks, and that That's unfortunate. I really need a jack. So there's an out of context moment for everybody. Anyway, I've got that there just temporarily so that we can test the proof of concept. Obviously my Morse code is a little rusty. My keying is a little rusty. My wrist, as they call it, is a little I still need to practice, and that's why I built a CPO. Test 1 2, test 1 2. Test 1 2, test 1 2. Can you hear me now? So as you can see, I'm working on stuff, and that same amplifier circuit I think will work great for this camera phone. So the thing about it is I did a test video with this hooked up to the phone as a microphone source, and I could sit back in my chair. I had the microphone 2 feet away from me, and I was talking in a conversational tone. Yes, it sounded a little bit hollow. You could tell that I wasn't right up on the microphone, but it was actually pretty good audio. Not great, not professional broadcast quality or anything, but it was certainly audible. I mean, you could definitely hear me. You could tell what I was saying. There was no question. So yeah, I've got some very simple modifications I can do to a microphone that will actually work for these videos that I do. And I am working on some stuff. I don't have time right now. I've got a whole bunch of other things in the house that I'm working on, and I'm taking care of electronics as a hobby when I have time. But I finally have this done. Let me show you the insides. So obviously we have an Altoids tin attached to another Altoids tin. I took the lid off of the bottom one, of course, cut a hole in the top one, and I left flaps so that I could bend it down. And these are just those little jewelry eyelets. Or maybe not jewelry, but you know, honestly, I don't know what they use them for. They're decoration, I guess. Maybe you put them on shoes. There's one, and there's the other. But basically, they're kind of like rivets. One goes inside the other with something sandwiched between them, and there's a special pair of pliers that spreads them out. It's not a pop rivet. The pliers themselves spread this out. In fact, they make mandrels that you can use with a press to attach those properly. Of course, I don't have one, so I had to make do with a couple of tiny little metal ball bearings on a pair of channel lock pliers. And that's why it looks like total crap. Okay, I mean, these are not done right. This is a proof of concept, people. This is not my final product. At least not what I would have. On the inside, you can see I've got the 4 switches. These are ganged together, obviously, the radio push button, radio button style. So I push one in, the other 4 go out, or the other 3 go out. That's how they're attached. Each one of them is a 4-pole, 2-throw, 4-position, 2-contact, or contactor, wiper, whatever you want to call it, switch. So basically, the way they're wired, I have 6 terminals. Right there's the middle. So the top 3 terminals are one single-pole double-throw switch, and the bottom are another single-pole double-throw, and then I've got a single-pole double-throw here and a single-pole double-throw here. And all 4 of them are ganged together, of course, in the one housing, causing it to be a 4-pole, 2-throw switch. And then, of course, the 4 of them ganged together as radio button. On the underside, you can see it on this one over here. I've kind of spread them out to make room for the battery underneath, because I didn't realize how little clearance I would have, and I wasn't quite ready to just trim them off yet. So I'm trying to leave those somewhat intact. Of course, I'd have to undo 2 nuts, 2 screws, in order to get the switches out, not to mention pulling off all of the red things to keep them from getting scraped up on the inside of the Altoid tin, which is kind of rough cut, honestly. But you can see underneath I've got the circuitry. Now you can see it, kind of. There's and it's just a couple of really easy circuits, really simple things. But you got to be careful, because if you get one wire in the wrong place, you'll wind up spending 2 days troubleshooting it, like I did. But the circuit itself, let me go ahead and make sure this is off. I'm going to unplug that. I'm going to full on undo all of this, so I can just move this out of the way. Alright, I know this is going to be kind of difficult to make out. I did make a mistake, and that's why it took me 2 days, because I kept using this schematic to troubleshoot why the amplifier wasn't working correctly. And the problem is the collector of the first transistor in the amplifier has to go to the base of the PNP transistor, not the base of the NPN transistor. And I kept checking all of my wiring on this schematic, and that's why it wasn't working, because I had it wired to this schematic. Once I figured out my mistake, I've obviously corrected that. I went through several iterations of trying to wire the switches in such a way as I would only get power where I wanted it, when I wanted it. And as I kept on continuing to simplify it, I realized I could make do really with only 3 switches. And that's what I did. I've got it all wired up here. You can see A, B, C, D, E, F, and each one of these is A, B, C, D, E, F. So based on, you know, what I've got down here in the schematic, this is how it's wired on the switch set. So it's a pretty simple twin T oscillator. I've had a couple of other oscillator schematics that I've built, and they sound okay, but they're not good enough if I were to put them on the air. And granted, you wouldn't be putting this on the air modulated over as audio over the airwaves, unless you were doing a specific mode in FM on something like 2 meters down in the 144 into the range. And I haven't even looked into that. That might be something I get into one day, but not today. So really, this isn't good for an actual transmitter oscillator, but it is good for an audio oscillator. It is an absolutely pure, perfect, beautiful, clean sine wave. The other oscillators I've had were pretty much always based on a 555 timer or a pair of op amps, and I don't get that. Transistors are so much cheaper. Capacitors, resistors, they're simple enough components to put into the circuit. Go ahead and do that. What killed me, though, is these are 0.02 microfarad, or 20 picofarad, millimicro nano pico, yeah, nanofarad. So these are 20 nanofarad, and down here I've got 50 nanofarad. Well, of course, to get those, I've got 100 nanofarad, but I don't have 10 nanofarad or whatever. I wound up, or actually I have 10 nanofarad. I don't have 20. I wound up having to yeah, that's what I had. I had 10 nanofarad, and I put 2 10s in parallel here and 5 10s in parallel here to get the 50 that I needed for those and the 20 I needed for those. Very annoying. This is part of why I do this. I'm learning. There's another schematic that actually showed these as being 10 nanofarad, and these were, I forget what value, but they were values I actually had in my box. But I had already soldered together the capacitors to get these values that I needed. So by that point it was, I may as well go ahead and commit. But I found a different circuit that had different values for everything. It's basically the same circuit, just different values for everything, and it would have worked just as well. And then we have here a Class AB transistor amplifier that I found on electronicstutorials.ws, I think it is. And basically you have a little bit of a preamp here that goes into an Class B. So you have a Class A amplifier and then a Class B amplifier. The Class B amplifier is biased with these diodes here so that you can get a smooth transition between the two transistors when your waveform goes positive or negative. And I've discovered that you can put a variable resistor, potentiometer, whatever you want to call it, between the collector and the base of the Class A transistor amplifier there and get basically a gain control or a volume control. Not that you generally would need it, but it could come in handy for certain cases, like if you were attaching it to a camera phone, for instance, and you don't want to overdrive your inputs. But basically that's it. I mean, there's really nothing there. Power for the microphone and just different connections based on where you have your switches positioned. Nothing to it. You could probably, if you were experienced, you could probably build this in an hour or two. I'm not experienced. It took me about a week or two just to put this stuff together, and then another couple of days of troubleshooting and diagnoses. And honestly, that's pretty much it. You know, when you've only got a few hours a week to work on something like that, it does take a couple of weeks, especially when you write down the wrong, you copy your schematic wrong, which is easy to do when you're constantly looking at pairs of nearly identical items, complementary items, a PNP and an NPN, for instance. And then you've got your diodes that have to go a certain way, and then when you start putting it on the breadboard and you realize that the positions you got to put everything in, because I was doing it one thing at a time, going from one end of the schematic to the other, and realizing that if I turn around this transistor and I can get it to, you know, be arranged differently, it'll be more convenient for the wires that I've got going to them. And then I wound up with the NPN and the PNP flipped versus what's in the schematic. Electronically, it matches the schematic, but they were flipped physically. And then I wound up, I got something in my eye. I got a fan down here at the floor blowing stuff in my eyes, so it's all great. But in the end, between having the physical location flipped and then having the pins flipped, because I had one of them turned around so that the emitters could be together. Or was that the no, the emitters, so the emitters could be together. And then flipping the entire circuit board over on its backside, so I'm looking at the solder side, so everything's flipped there. It gets to be confusing, especially when you only get an hour to 3 hours a week to look at something like that. So, word to the wise, if you're going to be doing a lot of this stuff, set up a work where you're free of distraction, and set a time where you can work on it. And only that, and not have to go do chores, not have to go and pick anybody up from school or drop anybody off at the movie theater. Make sure you're free of distractions. But hey, that's what I've been working on, and I wanted to share it with everybody. So I've got myself a code practice oscillator that I can improve my CW with, and an audio amplifier that I can tie directly into a radio whenever I get around to building one. So I'm going to wind up that circuit that I just showed you be actual transceiver one of these days. Anyway, that's all I got, and I'm trying to keep this under 20 minutes, and I'm getting pretty close to that marker. So 73, everybody, thank you for watching. If you like the video, subscribe. I've got more garbage like this coming up. I know I don't have a whole lot of high opinion myself on these. This is just my fun. I'm just wanting to share it with people. So like I say, 73, see you next time.